All right, so I'm going to give you two different kinds of special transformations. The first one is a Bernoulli. No, I don't know which one of the Bernoullis this was named after. There were a whole mess of those guys. I'm serious. Did you guys not know this?
Jacob.
There's like 25 freaking Bernoullis. This one's Jacob Bernoulli? Okay. I don't know which one that is.
It's Jacob.
The one who drove Newton crazy.
Oh, cool. Good man. Dude, was it? Okay. Bernoulli. Bernoulli equations are of the form y prime plus p of x y, which, of course, we have seen. Yes?
Yeah.
Equals f of x y to some power r.
And that's a polynomial, not a derivative power type thing?
Yeah, if I wanted to take a derivative, I'd have little parentheses around it. Did I tell you guys that notation? This thing?
Okay.
Y with a little 4 that looks like an exponent but has parentheses around it is quadruple prime.
So it was about y.
Well, don't worry, it's worse. The physics people do this thing.
Oh, the hats?
Yeah.
Dots. They do dots. I don't know why.
That moment.
Sure.
Everyone when it gets really big, like,
I
they
don't know.
not need to go that big. Or,
They do the same. They do this same thing after a few.
yeah.
Anyway, point is, yeah, that's an R. So, a good way to solve this might be to do variation of parameters, which we could do. Right?
Yeah.
Why could I do variation of parameters to this?
We could turn that to a homogeneous linear if we kill the right side.
Hey, if f of x is...
Yeah, like if I
always
drop
0,
this stuff, right, then that's a homogeneous linear equation,
Yeah.
right? And then it might be reasonable for me to just try variation of parameters on this thing anyway, even though it doesn't actually fit the form. What's the form actually include?
It's just f of x.
Yeah, there's no y of r on this
Yeah.
side, right? So normally you'd like solve the homogeneous version, right? And then you'd guess some u times your homogeneous solution, and you'd cram that in and you'd fiddle with it, and you would eventually find out that this makes everything separable that way. Okay? So you could solve this using variation of parameters if you like forget how variation of parameters is supposed to work and just do it anyway. Like, it'll still work. But I want to highlight kind of a different trick. So the trick I'm going to highlight is I want to guess if v is y to the 1 minus r. Does this seem like a good idea?
So if you divide y to the r by v, you'll just get y, right?
If I divide y to the r, oh, if I divide v by y to the r,
Or if you plug in v, you just get
I
v.
think if I multiply v by y to the r, I'll get
Yeah.
y. Yeah.
Where are you plugging in?
There, yeah.
This side?
Good question. I don't have a v in that equation, right? So what the heck is up with this?
Like this, how would you do that,
I
right?
could have a v in that. How would I do that?
Divide everything by y to the r.
Oh, that's a good idea. If we divided everything by y to the r, right? Then I would have a v right here. I would have something hopelessly annoying right here.
Oh. Yeah.
You guys see that? But my claim is this is a little bit like u substitution,
Looks like it.
right? It kind of looks like u substitution. I'm going to try it like it's u substitution. So what's the next thing I should calculate here? Seems like dv dx should be a good idea, right? V prime, right? Should be what? What do you get?
Minus r. 1 minus r. 1 minus.
1 minus r.
And then y to the negative.
Y to the minus r
Times y, dy dx.
times the derivative of the inside, right? So I got dv dx is drag the power down, y to the one lower power times the derivative of y. You guys all with me? Okay, now, my claim was that was actually a good idea. Wait for it. No, it doesn't seem obvious yet. So, let me take my equation that I had, and I'm going to multiply this whole thing through by 1 over y to the r. Because that seemed like a good idea, actually. So I got y prime over y to the r plus p of x times, what did you say you got here?
V.
That's a v, right? Because it's a y divided up by a y to the r. So that's a y to the 1 minus r, right? I'll write it as 1 minus r here, but really what I'm thinking is that's a v, man. On the other side, what have I got?
F of x.
Yeah, there's an f of x left over there. Okay, how helpful was that?
You got f of x by itself.
I got f of x by itself, that's cool. I got a y to the 1 minus r, that's a v. Cool. If only I could get rid of that first bit of crud, right? Y prime divided by y to the r. Like if I could get that in terms of v, then I'd be set.
If you integrated dv,
Don't do that.
no,
Easier.
If you played around with this other thing over here, plug in that somewhere.
What's that thing?
1 over.
That's 1 over y to the r times dy dx, right? That's 1 over y to the r times y prime. Right? Totally cheating. Yeah, so that's that thing. Right, so you got your first term. Well, almost. What do you need? So what else do you have here?
1 minus r.
Yeah, you got a 1 minus r, which is what category of thing? Yeah, that's a scalar, right? That's just a number. So what am I going to do with that?
Cram it in.
Yeah, I'm going to shove it on the other side. So I got a 1 over 1 minus r times v prime plus p of x v, right? Equals f of x. And now you're not quite in the right form, but you are really darn close. Yeah, clear your denominator there. So you got v prime plus 1 minus r p of x. V is f of x. Right? And then you can solve this in the usual. Cool, cool? Questions, things?
Why didn't the f of x be implied by 1 minus
Oh, just because I'm an idiot. Thank you. Okay, it's good with this? Kind of makes sense? Okay, so this falls under this is a good trick to remember occasionally. It's a really good trick to remember if you happen to do something that has lots of Bernoulli equations in it. There's apparently a field that has lots of Bernoulli equations in it. I don't actually know what it is. I don't know.
Sounds probable.
Probably another one.
I think it's
Okay.
fluid.
Fluids, I believe, but yeah, don't quote me on that. So, the thing you should remember about Bernoulli's is this guess of v equals 1 minus r, and then this trick, right? Just pretend it's u substitution, like think u sub, and then know where you're supposed to end up. Where are you supposed to end up?
Linear type scale.
Yeah, you're supposed to fiddle this and get linear equation.
So if R was like 5, if our V guess then would be like Y to the -4. Seems so weird that it works out like that.
Yeah. It is a little weird. This is one of those things that you chalk up as like, somebody spent a long time fiddling with this for some reason, and then happened upon a good substitution. Right? Like this was somebody who was seriously frustrated by a problem that they were working on, and they tried a bunch of stuff, and then they happened into this. They were probably doing a combination of reverse engineering what was happening and trying guesses and seeing how close they could get and trying to reconcile both ends. Right? Like this is a hard thing to come up with the first time. But to recognize this kind of beast is not particularly hard. It's just like, oh yeah, that's a linear first order differential equation that's not homogeneous. Oh crap, there's a y over there. Right? So if you find yourself thinking, oh, there's a y over there and there's not supposed to be, then welcome to Bernoulli land. Oh yeah, I should guess y to the 1 minus the power of y over there. Or divide through by the y's and notice that, oh yeah, that's a Bernoulli thing. What else?
So you have to go back at the end and solve for y, take b to the r power or what?
Yep, so at the end here you'll get some answer for b, right?
Right.
You'll take that answer and you'll feed it back in here. You guys cool with us? You want to try one? No.
That's not